Hello, everybody, and Merry Christmas to those of you who celebrate. Welcome into another lesson. So, today we are going to talk about absolute value equations and inequalities. So, if we look at the absolute value of a number, if we remember the absolute value, it's always going to give you a result that's either 0 or greater. So the lowest number you could have for the absolute value is 0. And I have the most basic one here, the absolute value of x equals 1. Well, whether I stick a positive 1 or negative 1 in for x, I'll still get 1. So when you're considering the absolute value equation, you just take x, so remove the absolute value, take x, set it equal to 1, and then you'll have, of course, you take x, set it equal to the negative of 1. And if you put 1 or negative 1 in for x, you'll get positive 1. So you could say that x equals both plus and minus 1 for the solutions. Pretty simple for that. Now, what if I threw at you, I'm just going to change this slightly. What if I gave you the absolute value of x equals negative 1? What if I gave you that? Well, if you think about it with the absolute value, you will never get a solution where it's negative. The absolute value of any number is never negative. It's always 0 or positive, right? So to this one, there would be no solution. We have no solution to this. The absolute value is never negative. So that's something to keep in mind with absolute values. Now we'll demonstrate here with some equations, then we'll move on to absolute value inequalities. Alright, so let's say you have the absolute value of 11 plus 2x is equal to 5. So we have the absolute value of 11 plus 2x equals 5. So what you're going to want to do then, take this 11 plus 2x, so always take what's inside your absolute value. In this case, it's 11 plus 2x. You'll set it equal to the original of 5, and you'll have another solution. You'll do 11 plus 2x. So again, take what's inside your function, set it equal to the negative of what's on the right hand side. So 11 plus 2x would equal negative 5. Now we can solve this. So if we go to solve here, 11 plus 2x equals 5, well obviously we want to get the 2x by itself first, so subtract 11 from both sides. You would get that 2x equals negative 6, and then you would get that x equals negative 3. Alright, and then we come over here, 11 plus 2x equals negative 5. Get the 2x by itself, so subtract 11 from both sides. You would get that 2x equals negative 16, which would end up giving you that x equals negative 8. And I guarantee you, if you stuck in each of these solutions, you would end up getting, in fact, that both of those would actually equal 5. So your solutions here are x equals negative 8 and negative 3. Those are the solutions for x. So in general, you're going to have two solutions for an absolute value equation. In general, unless it's the absolute value of x equals 0, then it can only equal 0. X can only equal 0 at that point, but that's the only time you'd really have one solution. Alright, so let's say we have the absolute value of 10 minus 4x is equal to 2. So the absolute value of 10 minus 4x equals 2. So we'll go ahead, we'll set what's inside the absolute value, which is 10 minus 4x. We'll set that equal to 2, and Then you'll take that 10 minus 4x, set it equal to negative 2. So then just solve each of these equations for x. So on the first one, get the negative 4x by itself, subtract 10 from both sides. You would get that negative 4x equals negative 8, which would give you that x equals positive 2. And then 10 minus 4x equals negative 2. Get the negative 4x by itself, so subtract 10 from both sides. You would get that negative 4x equals negative 12, which would end up then giving you that x equals 3. Then if you stuck them both in here, you would get a true statement. Those would both equal the absolute value of 2. The absolute value would equal 2. So your solutions for this are x equals both 2 and 3. Those would be the solutions to this equation. All right. Let's see here. We have the absolute value of 22 minus 3n is equal to 5. All right, so we got the absolute value of 22 minus 3n equals 5. So take what's inside your absolute value, which is the 22 minus 3n, set that equal to 5, and then you're also going to take what's inside the absolute value, that 22 minus 3n. This time you'll set it equal to negative 5. And then you solve each equation for n, get negative 3n by itself. You would end up getting that negative 3n equals negative 17. And then get the negative 3n by itself again. You would get that negative 3n equals negative 27. Which then solve for n here, you would end up getting n equals 17 thirds. And then solve for n here, you'd end up getting n equals 9. So you have two solutions then. N would equal both 17 thirds, and then it would also equal 9. So those are your two solutions for n, 17 thirds and 9. All right, next we have the absolute value of 2n minus 5 equals 7. So the absolute value of 2n minus 5 equals 7. So take what's inside that 2n minus 5, set that equal to 7, and then you're also going to take what's inside the absolute value, that 2n minus 5, you'll set that equal to negative 7. Now we just solve for n for each one. So you would get 2n equals 12, which n would equal 6. And then you would have 2n, solve for 2n here, you would end up having 2n equals negative 2, which would end up giving you n equals negative 1. So your two solutions for n are going to be negative 1 and positive 6. Those would be the two solutions for n, negative 1 and positive 6. And if you're ever curious if you got it right, stick each of these into the absolute value. You should get a true statement. All right. We have the absolute value of 8x plus 1 equals 23. So we're given the absolute value of 8x plus 1 equals 23. So take your 8x plus 1, set that equal to 23, and then you'll end up taking that 8x plus 1, you'll set that equal to the negative of 23. So then solve for x on each of these separately. You would have 8x equals 22, which would then give you that x equals 22/8, which reduces to 11/4. So x would equal 11/4, and then over here the 8x plus 1 equals negative 23. You would have that 8x equals negative 24, which would just give you that x equals negative 3. So your two solutions for x are going to be negative 3 and then positive 11/4. Those would be your two solutions for this absolute value equation, negative 3 and positive 11/4 rather. All right. So we have the absolute value of 30 minus 7x equals 4. Whoops, I wrote that kind of wrong. Hold on. The absolute value of 30 minus 7x is all equal to 4. So let's go ahead then, write two separate equations. So 30 minus 7x, of course, would equal 4, and you would then have 30 minus 7x would also equal negative 4. So now, of course, we'll solve for x on both of these. You would end up getting negative 7x would equal negative 26, and, well, I'll wait a minute on that. We'll solve one at a time, which would give you x equals 26/7 for your first solution. And then 30 minus 7x equals negative 4, you would get negative 7x equals negative 34, which would end up giving you x equals 34/7. So your two solutions to this are going to be x equals 26/7 and 34/7. Those would be your two solutions, x equals 26/7 and 34/7. Alright, so let's see. We have the absolute value of 1/4 x minus 5. That's all going to be equal to 8. So then you will take, of course, each equation separately. So take your 1/4 x minus 5, set that equal to 8, and then you will take your 1/4 x minus 5, you'll set that equal to negative 8. So then solve for 1/4 x for each of these. To start with, you would end up having 1/4 x equals 13, which would give you for the first solution that x equals 52. And then 1/4 x minus 5 equals negative 8. That would give you 1/4 x would equal negative 3, which would give you that x equals negative 12. So your two solutions are going to be x equals negative 12 and then positive 52. Those are the two solutions for this, negative 12 and 52. Alright, we have the absolute value of 2/3 x plus 2 is equal to 10. So the absolute value of 2/3 x plus 2 equals 10. So first we will do 2/3 x plus 2 equals 10, and we will also have that 2/3 x plus 2 equals -10. So let's solve for each of these separately. You'd then get 2/3 x equals 8, 2x equals 24, which would then give you that x equals 12 for your first solution. Now solve for 2/3 x plus 2 equals -10. That would give you 2/3 x equals -12, which would give you 2x equals -36, which would give you that x equals -18 for your other solution. So the two solutions to x are -18 and +12. So -18 and +12 are both your answers to this. One more equality, then we're going to do some inequalities. All right. So then we have 1/2 x minus 3. The absolute value of 1/2 x minus 3 equals 2. So of course, take each of these, do a 1/2 x minus 3 equals 2, and do a 1/2 x minus 3 equals -2. Then solve for x separately in each of these equations. So half of x minus 3 equals +2. That would give you half of x equals 5, which would then give you that x equals 10. Now let's solve for half of x minus 3 equals -2. So that would give you that half of x equals 1, which would give you that x equals 2. So then your two solutions to this equation are going to be x equals 2 and 10. So 2 and 10 are your solutions to this equation. Alright, so that's it for the equations. Let's move on to absolute value inequalities. Let's say we'll do something simple here. Let's say we have the absolute value of x is greater than 1. So the absolute value of x is greater than 1. So if it's greater, I'm going to show you how this works. You're going to solve this much like you would for an equality, but it's different. So you would end up taking x is greater than 1 as one of your solutions. But then you're going to, for your next solution, you're going to deal with x and -1, but when you go for the negative side of it, you're going to flip your sign. You would end up having x is less than -1. So you end up getting that x is greater than 1 or x is less than -1. So how can you remember this? If it's ever an absolute value of something that's greater than a number, which here's your solution, x is greater than 1 or x is less than -1. So if it's greater, remember greater. Greater for greater. So if you have the absolute value of something greater than a number, remember greater. It'll split it into two or statements for your solutions. Now, I'll demonstrate with the and. I'll demonstrate if it's less than 1. What if we had the absolute value of x this time was less than 1? So again, you're going to start out solving this much the same way. You're going to start out with the fact that x is less than 1, but when you go to deal with -1, for x and -1, you'll flip the sign. You'll flip the sign to x is greater than -1. So what do you know? You have x is less than 1 and x is greater than -1. Well, if x is greater than -1, that means that -1 is less than x, which then x is less than 1. So you can write your solution that -1 is less than x, which is less than 1. So how you can remember that, you have less than is how I'd remember it. So you have greater, then you have less than for absolute values. That's the best way to remember it. So let's solve some absolute value inequalities here. A simple one here. We have the absolute value of x plus 1 is less than 8. So we have the absolute value of x plus 1 is less than 8. Well, split these up into two separate equations or inequalities again. You'll truly have that x plus 1 is less than 8. So remember, this is less than. So x plus 1 is less than 8, and then you'll have x plus 1, you're going to flip the sign to deal with the -8, it would be greater than -8. And then you just solve these inequalities, you would end up having that x is less than 7, and x is greater than -9. Well, if x is greater than -9, that means that -9 is less than x, and then you have that x is less than 7. So your solution to this would be that -9 is less than x, which is less than 7. And if you're curious, just stick any value in this range in there, you'll get a true statement. All right. We have the absolute value of 12 minus x is less than or equal to 19. So the absolute value of 12 minus x is less than or equal to 19. Okay, so of course take your 12 minus x. You'll set that to less than or equal to 19, and then less than. Even if you have the equal to part, you still treat it as a less than. So, and you'll have that 12 minus x is greater than or equal to -19. So you just flip the sign to deal with the negative of what's on the right hand side. So now solve these inequalities. You would get that -x is less than or equal to 7, which now will flip the sign. You'll have that x is greater than or equal to -7. Now come over here, you would end up having, so 12 minus x is greater than or equal to -19. You would have -x is greater than or equal to -31. Which would give you that x is less than or equal to 31. So if you have x is greater than or equal to -7, well, that just means that -7 is less than or equal to x, and then x is less than or equal to 31. So that's how you can write these equations. That's how you can write your solution. -7 is less than or equal to x, which is less than or equal to 31. And if you put any of those values in between the two numbers or the two numbers themselves, you would get a true statement. Alright, the absolute value of 16 minus x is greater than or equal to 10. So we have the absolute value of 16 minus x is greater than or equal to 10. Well, split these into two separate inequalities. You would have that 16 minus x is greater than or equal to 10. Now if it's greater, so we have greater, or you would have 16 minus x is less than or equal to negative 10, since you flip the sign to deal with the negative of what's on the right hand side. Now solve each of these for x. So 16 minus x is greater than or equal to 10. Well, you would get that negative x is greater than or equal to negative 6, which would give you that x is less than or equal to 6. And then solve for 16 minus x is less than or equal to negative 10. You would get that negative x is less than or equal to negative 26, which would end up giving you that x is greater than or equal to 26. So x is less than or equal to 6, or x is greater than or equal to 26. So you see you have two disjoint solution sets that don't overlap at all. X is either less than or equal to 6, or x is either greater than or equal to 26. That would be the solutions. And if you put in any values in those ranges, you would get a true statement. Alright, so what if, this will be easy. So we have the absolute value of x plus 5 is greater than 12. So the absolute value of x plus 5 is greater than 12. Well, of course, you're going to have two inequalities then. You'll end up having, of course, x plus 5 is greater than 12. So remember, greater, or you'll have that x plus 5 is less than negative 12. So then solve each of these inequalities for x. You would end up having that x is greater than 7, or you'll have that x is less than negative 17. And those would be your solutions, that x is greater than 7 or x is less than negative 17. All right, the absolute value of x minus 8 is less than or equal to 5. So the absolute value of x minus 8 is less than or equal to 5. So you'll start out, of course, with x minus 8 itself is less than or equal to 5. So you have less than. So x minus 8 is less than or equal to 5, and x minus 8 would be greater than or equal to negative 5. So solve each of these inequalities, you would end up getting that x is less than or equal to 13, and x is greater than or equal to 3. All right, so if x is greater than or equal to 3, that means 3 is less than or equal to x, and then you have that x is less than or equal to 13. So whenever you have an and set, you'll have one compound inequality. So the solution here is that 3 is less than or equal to x, which is less than or equal to 13. If you have or, you have disjoint sets then. All right. Absolute value of x minus 16 is greater than 24. So we have the absolute value of x minus 16 is greater than 24. Well, of course, you'll end up with x minus 16 itself is greater than 24. Now, great Tor, so you'll have or x minus 16 is less than negative 24. So that's going to give you two solutions here. You'll end up having that x is greater than 40, or you'll have that x is less than negative 8. So those are your two solutions that would make this inequality true. X is greater than 40 or x is less than negative 8. All right, we're down to the last 6. We're coming there. All right, so the absolute value of 14 minus 3x is greater than 18. All right, so the absolute value of 14 minus 3x is greater than 18. Well, of course, you'll start out with 14 minus 3x itself is greater than 18. Then you have great Tor. So you'd have or 14 minus 3x is less than negative 18. So now solve each of these inequalities. You start with negative 3x is greater than 4, which would end up giving you that x is less than negative 4/3. And then come over here, 14 minus 3x is less than negative 18. So you'd end up having negative 3x is less than negative 32, which would end up giving you x is greater than 32/3. So you end up getting that x is less than negative 4/3, or x is greater than 32/3 for your solutions. Those would be your solutions then. That x is less than negative 4/3, or it's greater than 32/3. All right, 5 more. We have the absolute value of 4x plus 10. All right, that's just less than 20. Okay. So the absolute value of 4x plus 10 is less than 20. So you're going to do your two separate inequalities again. So you would end up taking that 4x plus 10 itself is less than 20. So less than. So then you would have and 4x plus 10 is greater than negative 20. So solve each of these inequalities. You would end up 4x plus 10 is less than 20 would give you that 4x is less than 10. Which means x would be less than, not equal to, certainly not equal to, x would be less than 5/2. So we have x is less than 5/2. Now come over here, 4x plus 10 is greater than negative 20. That would end up giving you 4x is greater than negative 30, which would give you that x is greater than negative 15/2. So if x is greater than negative 15 halves, that means that negative 15 halves is less than x, and then x is less than 5 halves. So you can write this as a compound inequality. Whenever you end up with an and, you always get a compound inequality. So negative 15 halves is less than x, which is less than 5 halves. That would be your solution to this. All right. Should have about 4 more here. So the absolute value of 8x plus 28 is greater than or equal to 32. All right, so we have the absolute value of 8x plus 28 is greater than or equal to 32. So let's do two separate inequalities again. So take 8x plus 28 itself. Of course, you'll set that greater than or equal to 32. Now you have greater. So you'd have then or 8x plus 28 is less than or equal to negative 32. So then solve each of these inequalities. 8x plus 28 is greater than or equal to 32. That would give you that 8x is greater than or equal to 4, which would give you that x is greater than or equal to 1/2. And then you have 8x plus 28 is less than or equal to negative 32. Well, you would end up getting that 8x is less than or equal to negative 60, which would end up giving you that x is less than or equal to negative 15 halves. So this is your solution to this inequality. You have that x is greater than or equal to 1/2, or x is less than or equal to negative 15 halves. Those are both your solutions to this inequality. Three more. All right, the absolute value of 20 plus 1/2 x is greater than 6. All right, so the absolute value of 20 plus 1/2 x is greater than 6. So we'll go ahead and split these into two separate inequalities. Of course, you'll have 20 plus 1/2 x itself is greater than 6. So greater means you'll have an or. You'll have that 20 plus 1/2 x would turn less than negative 6. So now solve your two inequalities. Get the 1/2 x by itself on the 20 plus 1/2 x is greater than 6. You would get that 1/2 x is greater than negative 14, which would end up then giving you that x is greater than negative 28. So x is greater than negative 28. Then do 20 plus 1/2 x is less than negative 6. So this would give you that 1/2 x is less than negative 26, which would give you that x is less than negative 52. So the solution here for this absolute value inequality is that x is greater than negative 28 or x is less than negative 52. Two more and then we're done. All right, the absolute value of 7x plus 5 is less than 23. So we have the absolute value of 7x plus 5 is less than 23. Well, let's split these up here. So we'll first start with 7x plus 5 itself will be less than 23. So now you have less than. So 7x plus 5 is less than 23, and 7x plus 5 is greater than negative 23. Now solve these two inequalities. 7x plus 5 is less than 23 would give you that 7x is less than 18, which would give you that x is less than 18/7. Alright, and then 7x plus 5 is greater than negative 23. That would give you 7x is greater than negative 28, which would give you that x is greater than negative 4. So since you have and, you'll have a compound inequality. If x is greater than negative 4, that means that negative 4 is less than x, and then x is less than 18/7. So the solution to this inequality is that negative 4 is less than x, which is less than 18/7. One more problem, then we're done. All right, we have the absolute value. Whoops, why am I doing two absolute value signs? That made no sense. The absolute value of 11 plus 6x is less than or equal to 47. All right, so the absolute value of 11 plus 6x is less than or equal to 47. So let's go ahead here and let's split these into two separate inequalities. So you'll have 11 plus 6x itself would be less than or equal to 47. And then less than, so you'll use an and. You'll have 11 plus 6x is greater than or equal to negative 47. Alright, so now solve for 11 plus 6x is less than or equal to 47. You would get that 6x is less than or equal to 36, which would give you that x is less than or equal to 6. Now, we have that 11 plus 6x is greater than or equal to negative 47. You subtract another 11, you'll have that 6x is greater than or equal to negative 58. So then x would be greater than or equal to negative 58/6. That would be negative 29/3. So then you would have that x is greater than or equal to negative 29/3. So if x is greater than or equal to negative 29/3, that means that negative 29/3 is less than or equal to x, and then x is less than or equal to 6. So the solution to this inequality would be negative 29/3 is less than or equal to x, which is less than or equal to 6. So that's it for this lesson. Next lesson, we're going to start talking about linear functions and their graphs. Algebra 2 is more intensive on graphing than the previous courses were. So it's going to seem largely like a review in the next lesson, but we're going to start out with linear functions and their graphs. So I hope everybody has a great day. Merry Christmas again to everybody. Take care, be safe, and I'll see you all in the next lesson.